Great. Sounds great.
So we're recording. We're good to go.
Hi, Adriana and Elizabeth. How are you doing? Thank you for joining me. My name is Pamela Dixon Kuhn. I'm going to share my screen and start my presentation. But please, oh, hi, Elizabeth.
Hey guys.
At any time, if you'd like to jump in, feel free. If I keep going, just unmute yourself and join in. So let me see if I could do this. Here we go. Okay, so today I just wanted to talk a little bit about developing a science research program and the benefits possibly to you and your school. So my name is Pamela Dixon Kuhn, and I was the director of a science research program for about 10 years. And the school that I taught in, it was a regular public high school. It was not a specialized science school or anything like that. In fact, in New Jersey, we were smack dab, the ratings that schools have, we were right like smack dab in the middle. We were not anything special, but yet it was kind of an anomaly because we had this really phenomenal science research program. And when I first started, the first year that we started the program, I had 2 students. And by the end of the years of my tenure, the 10 years, I had over 60 students that were involved in the program. And what I noticed was that the students started having a lot of success, as Margaret was mentioning, because they did compete in various competitions, but they were starting to be very, very successful in local, regional, and even national competitions. Margaret, I think you had said the Intel that you were, you had, when you went to high school, some
Yep.
girl had won the Intel, which is a really prestigious competition. As well as some of my students even had their papers published in professional journals, and they would. I started to have students like getting accepted into Princeton, into MIT, various colleges that my school just had not had many students go to those universities, and the students were told that they had done such great research that schools became interested in them. But most importantly, besides all that, I noticed a really strong interest in science and STEM. So we all know that the problem exists, that there's a need for scientists and engineers in the United States. And unfortunately, the US in international assessments ranks not so well. I have a couple statistics. I think it's from the Pew Research. And I just got this today that 15-year-olds rank in the United States, rank 38th out of 71. In our students rank 38th in 71 countries in math and 24th in science. So you kind of just wonder, how could that be? I mean, we have so many students who have such, opportunities, that why are they ranking, not so well in these international assessments? Margaret probably knows why, but I sure don't. There's also a project, it's called the National Assessment of Educational Progress. And they recently came out that 4th and 8th graders, their math scores fell. And it was the first time since 1990, and probably COVID does have a large part to do with that, but they also ranked 12th graders, 25% of 12th graders as being proficient or advanced in science. So I think one of the fatal flaws in the United States is that a lot of students are excluded from STEM because of low expectations. I know when I taught, there were a lot of students who said, oh, I'm just not smart enough to do science, or I would never go into that math because the higher level math course, because I'm just not smart enough. And certainly people of color are underrepresented in STEM classrooms. I remember going into our AP classrooms, and not very many students of color were involved. In fact, in 1978, the Blacks who had a bachelor's degree who were actually working in STEM, there were only 7% in the United States. And today, Blacks with BS, the bachelor's degree working in STEM, is 7%. So not much progress since 1978 has been made. And so that really bothered me, especially as I would go to these competitions like Intel, and we would be in a national competition. There were very, very few Blacks represented. And I just couldn't figure out, like, why? Why is it that most of the students were either white or Asian? And so the problem of getting students into science, one of the solutions in the late 1950s, actually, all the way back into the 1950s, is they began these original high school research programs. And what they found was that students' enthusiasm, participation in STEM courses, and just long-term careers, it really, really helped them. So when students participate in an original science research program, it really helps them to be able to understand the scientific method and continue with a science or math career. And the problem with that was that the high achieving high school students would be the ones taking these courses, science research in the high school. And so therefore they had an advantage in college. If you've already done research and you've done it in your high school career, well, you go into college and you're used to doing research. So therefore, you know, those students had an advantage, and it was like a self-fulfilling prophecy where they would just, you know, do well because they had it prior. But what I started to think about was, what if all students would be expected to master science and math? And what if all students were given the opportunity to do science research in the high school? Would that help achievement? So after I got out of public education, I actually partnered with a leading STEM researcher. His name is Dr. David Drew. He's from California. And what we decided to do was that we decided to do an analysis of the students who I had in the 10 years of my career doing science research. And so what we looked at was the students that I had, what degree did they end up getting from a four-year institution? And also, what were they doing as a career? So what we found in analyzing these students was that 72% of them, of the students who went through my program that I did in my school, regular public high school, 72% of them acquired a STEM degree, compared to the students that didn't take the program but did take upper level science classes. 30% of those students got a STEM degree. And as far as a career, you might wonder, well, why, if 72% of them got a STEM degree, why aren't 72% of them working in a STEM career. And the reason was our parameters in deciding what to consider as a STEM career was that they had to be involved in research. So even though we had a student who became a doctor, a MD, we didn't count that as a STEM career. Although it was STEM related, it wasn't in research. So after I did that research, my mind was like, psh. So I said, I have a key to getting more students involved with STEM and STEM careers. So I decided to form a nonprofit organization called Science Research for All. And what we've been doing is we've been going around and instituting science research programs within a high school curriculum. So I just wanted today to just tell you a little bit about what we do, and hopefully you'll find it somewhat interesting. And again, if you have any questions as we go along, feel free to just blurt them out. So you might be wondering, what is a science research program? Well, a science research program in the high school is where students do individual and authentic original research. So they're not given any particular, protocol or procedure. They design everything from the get-go, from the beginning to the end. And they follow the scientific method. They choose what they want to study. So they're not told, okay, you have to do something on C. elegans. They could do anything they want within certain parameters. I used to have some kids who wanted to do something with the paranormal, ghosts. I was like, no, you can't. That is not something you could do. So I did have to limit them, but they got to choose whatever they wanted to study. And they do work in an independent manner. My students worked with professionals, so they were able to communicate with scientists actually working in the field. And I didn't have any tests, but they did get an assessment, and they were assessed by, we would have a meeting every 2 weeks, and we would discuss their progress. And there was a lot of self-assessment as well as just how far along they got with their project. And I was their science research director. So the teacher in school is their science research director. We have instituted, I had a certain 3-year program when I taught science research, but Science Research for All has actually put programs into in the school as a regular course. We've also developed a program within a certain subject area. And so we've taken our program that say I did within the 3 years and fit it within a biology course. We've also, of course, done high school and also middle school. Middle school is really important because that's where they get their foundation. And albeit that they're not going to do as an extensive project as the high school students, they still do really great research. We've recently instituted a program in Camden City Schools in New Jersey as an after-school science club. And also I've worked with a lot of homeschool parents as an independent study. So really could be fit into pretty much whatever your school wants it to be. Now you say, well, I've heard so many teachers who said, of all things, between COVID and everything else, that's the last thing I need to do is put something else into my curriculum. But it's actually really beneficial. To the school, it's very low cost. For my program, I got absolutely no funding at all. I sought grants and received a lot of grant money, but the students were all responsible for their own their own projects. So they would have to I had students who sought their own grants. I had students who called companies and got things donated to them. For the school, it increases your reputation and ranking. It really builds the science department. There was a lot of collaboration. At the end of the year, the school did a science symposium where we had all stakeholders, the students, the parents, the faculty. We had professionals come in. We had even central administration. So we had a huge end of school symposium, which turned out to be a really large event. And we also received a lot of recognition because we, as I said, we started winning national competitions. For the teacher, I in my 30 plus year career as a science teacher, I will say in the last 10 years that I did my science research program, I still get chills thinking about it. I mean, not to be overly dramatic, but it was such an awesome experience for me. Rather than teaching students content, it was going through the process with them, the scientific method with them. I also had a big opportunity to meet a lot of professional researchers, and I still keep in touch with them today. I did a lot of traveling with my students. I had various students who not only participated in competitions, but they were also invited to professional conferences. I had one student who was invited to speak at the American Association of Cancer Researchers, and she was the only high school student to ever speak in that conference. And so I went with her. She went with her parents. I went down with them, and it happened to be in Disney World, so we had a really nice trip. It's also just a lifetime learning experience. I had taught science for many years, but the things I learned through my students, because I was not an expert in everything, but as they learned things, and they would actually teach me things. And so I learned a lot through my students. And for the student, I mean, I could have kept going on my slide deck. I could have gone for several slides, but the students had so many benefits. They got so excited about their projects because they really took control of their own project. It was theirs. They were the stakeholder in this project. I noticed many of my students gained confidence in their science skills. They had to communicate with a mentor and me, and they also communicated with a lot of people in public. So they learned communication skills. For my course, they also had to write a paper, 15-page paper, 15 to 20-page paper on their research. So they actually wrote a journal article. They gained a lot of independence because nobody was really watching over them. They had to do it themselves. And these were regular students. These were not AP students. I had some AP students. I had some college prep students, general students, and I had special ed students. I had students from across the spectrum. The main thing I found was that they all had a very strong interest in science. So my student, and I had many, but the one student, and he was a special ed student, he got a full ride to New Jersey NJIT, and he is now a video game designer, but he had a really strong interest in video games. But it really taught him to be independent. They truly understand the scientific method because they have to do it. There's no getting around it. They actually are doing the scientific method. They're learning to read scientific literature. I can't tell you how many students of mine went to college and said, oh, I was the only one in my whole class who knew how to read a journal article. By the end of the 3 years, my students on average would have read between 30 to 50 journal articles. They also learned to present. They had to develop good time management skills because a lot of the students were involved in sports, AP classes, other extracurricular activities. So they had to manage this project within their time frame. As I said, they took ownership of their work and they had to develop creative thought. If something, which most times something didn't work out right, they had to think, there was nobody there giving them answers. They had to figure it out themselves. That my students were involved in 3 years. So it was including summers. So they didn't take a break. They didn't even take summers off. They would meet even in the summertime and would have to do work in the summer. So it really, they actually, most students felt like, they said, I feel like a scientist. I feel like I'm actually doing the work the scientists do, because it was a hands-on, authentic experience. And most of my students had colleges really interested in them because of their work. So Margaret and I were talking about there aren't very many schools that put science research programs into their curriculum. And I have noticed that most programs are in specialized STEM schools. If you go to any of these competitions, they're all highly specialized STEM schools. New Jersey, we have a school called High Tech High School. They have this program. They do all, the research. So it's not too common that regular public schools have this. And I really don't know why. One of the things is a false assumption that only high aptitude students could be successful in STEM. And that's certainly not true, especially from the research that I did. 72% of my students went into the and got a bachelor's degree in STEM. So I think a big problem also is that many teachers aren't familiar with the research process. In other words, if you have a teacher and they want to become a teacher, they go to college, they take classes, and they become well familiar with their content material. Let's say they're a chemistry teacher, but many teachers don't do research in college. So they're not familiar with the research process. So that's where we come in. We come in and we actually teach the teachers how to develop a science research program and how to do research with their students. So we work directly with educators, give them the tools that they need to lead a research program. And in doing that, we really try to focus on regular public schools as well as underserved schools, promoting equitable opportunities so we could get more underserved students within the STEM field. And we imagine a future where all students have the opportunity to engage in scientific research and are inspired to practice scientific method. So this is what, now, again, we could develop a program to whatever the school wants. We don't have to do a 3-year program, but this is the program that I did with my students, which can be adapted basically to any time frames. I've even put, just want to make sure I'm not running over. I've even put this program into a half a year because they had block scheduling. So in the sophomore year, we introduced the students to the general articles. They pick a subject. They start to read journal articles. They narrow a gap, what they could do, and they develop a research plan. All while they use a lab book, and I also had them do a portfolio binder, which was the basis for their assessment. In the junior year, that's where they actually conducted their research, and they did a preliminary trial. They kept a lot of notes in their lab book. They had to devise these timelines, making sure that they did their project within the appropriate amount of time. Most of them took pretty much their whole junior year to actually do their research. I know that sounds crazy, but some of their research was very, very involved. And most of my students were able to learn statistics on their own. A lot of them didn't even have statistics, but they used software in order to analyze their data. And then their senior years, when they did their paper and also used that time to present. So what we go over when we go into school is we teach the teachers how to recruit the students. Those students who are really, really excited about science. I don't know if any of you ever met any students who were like just really science students, like they loved it. And, we kind of have a way to recruit those students and get them involved with the program. And they feel almost like they're exceptional because they're doing the work that scientists actually do. And then the first step, of course, is reading general articles. I usually have them read at least 20. And these articles come from like Science News, Science Daily. And what I'll do is I'll tell the students to read 10 Science News articles. And I won't tell them what to do it in. I'll just say, just read any article that's interesting. And then they bring them in and I'll say, okay, take those articles and I want you to order them from something that you're most interested in to the least interested in. And so as they put their articles in order, the ones that come to the top, then I'll say, okay, well, why don't you take that topic and find out more about it and look up more articles. So by doing that, they're narrowing down the topic. And they finally come, after a couple of weeks, they finally come to a topic that they're interested in. And then we get them involved with science journal articles. And that's really difficult because they have a difficult time. Anybody has a difficult time reading scientific journal articles, but we teach them the different parts of the journal article, the abstract, the introduction, the methodology. And in order to do the methodology, what we have them do, and this is just a little technique that we encourage our teachers to do, they actually do a cartoon of the methodology. So I don't know if you have a little piece of paper there or not. Anybody have a piece of paper and a pen? Okay, great. We could try this. All right. So let's say we were reading a journal article, and this is the methodology that they are talking about. And this is not real. I just made this up today. So there's 2 mice, 1 male, 1 female, and they're placed in a contained area. Another mouse, a female mouse, number 2, she's placed in a separate contained area inside the original container. The 2 mice, 1 and 1, were fed M&Ms. And after 30 minutes, female 1, this one up here, the original female 1, she started carrying M&Ms to the contained female 2 mouse. the male mouse, number one, did not feed the female. So if you could just take a look at that methodology, and we'll just take a minute or so. And if you could just draw that, put it in like a cartoon or a drawing. Let me see, Adriana. Oh, that's really, Adriana, could you explain that? Like point to your.
1 second. So yeah, so we have female one and male in this area, and then you got it separated by a barrier. I'm assuming it has like an entrance, and then female one can take it to female two, and the M&Ms are at the top. And then here's like to indicate that that transfer did not happen.
That male mouse, I'll tell you. So, yeah, and so this is mine. Here's a container and male, female. Here's the female mouse in a separate container. And then we have the female and male were fed M&Ms, and the female here, no M&Ms. And then after 30 minutes, the male keeps chomping down those M&Ms, but the female number one, I'm going to give you some, and then she gave it to the contained. So therefore, just an example of the methodology that we use. And the students really, instead of reading the methodology, because in a journal article, sometimes it gets very, very complicated. This technique really helps to actually draw out the methodology. Right. There we go. So the next step is the research plan. So this is the beginning of the students' research. So they know what they want to do, and they've read a lot about it, and they've read a lot even in journal articles. So what they want to do here is they want to find an original, and this is a key word, they want to find an original research question. What's the gap in the research? So let's say, and again, this is silly, but I'm going to do it anyway. They know from journal articles that cinnamon has antibacterial properties. They also read another journal article that lemongrass has antibacterial properties. That we know. We also know that cumin has antibacterial properties. So we know this from reading our journal articles. But a student says, you know, my grandma, she always uses oregano and she's never sick. So she uses oregano on the pizza she makes, you know. So the student starts looking in journal articles. Does oregano have antibacterial properties? And guess what? There's nothing in the journal article readings. They can't find anything. So they say, the student says, I don't know. Is oregano, does that contain antibacterial properties? So that's the gap. That's the thing in research. That's the original. So we could take these and even use the methodology that they used for these, and we could incorporate it using a new variable. So at this point, I would have my students search out for a mentor, somebody working in the field of bacteria, you know. And so we have techniques which we had the students contact a professional researcher, and we had about 72 to 75% success rate with this technique. And they would email and they would use certain words, and they would never ask, will you be my mentor? Because somebody would say, no, I don't want to deal with a high school student. But, you know, there's a way to kind of get around it and kind of like hook them in. So at this point, the student would have a mentor. And I would have students that would have mentors like halfway around the world. I had a student whose mentor was in New Zealand, and they just kept in touch. You know, today it's so easy with Zoom, with email. I mean, there's so many ways that they could get in contact with a professional researcher. At this point, before they began their research, I would always have them complete the ISEF forms to make sure everything was good and they were doing things properly. And if they worked with human subjects, I actually developed a IRB board within my school, which was my science supervisor, my principal, the school nurse, and the school psychologist. And they would, if a student did work with human subjects, they would just look at that project and approve it. And then came the fun part. During the junior year, they would actually do their experiment. Now, you might ask, well, where did they do it? Some students did it at home. Some students did it in a lab, university lab. Some students did it outside. I had a student who did a project with migrating birds, and it was right outside. It all depends on the project, but certainly they all were able to develop their experiment, and they developed it with the location in mind. After they collected their data, then they actually analyzed their data. I had them use a statistical analysis program, which is free and it's online. And I have tons of free materials that students could use. I have, for instance, if your student wanted to do a project with something in botany, like the University of Kansas, they'll give your students whatever they want. And I had a student who they actually measured the length of the leaves. And there's so many resources where, if that's a worry, like, well, where would they get the money to do this project? There's just tons and tons of free stuff out there. And there's tons also of grants available. At this point, then my students would do a research paper, and from reading so many journal articles, they were actually familiar with the setup. And this is one of my students. His name was Ryan Larson. He actually had, and here's me, he worked with a PhD, Catherine Ruther. I think she's actually at Princeton now, and I can't be sure. She was at Columbia when we did this with her, but I know she's moved on. But we actually got published in the Journal of Shoulder and Elbow Surgery. So when Ryan went, and he was published as a senior in high school. So when he did his college applications, he was able to put on his application that he was published, which was a big help for him. I always had in the senior year, my students practice and do a poster presentation as well as a slide deck. And that's what they used for the end of year symposium. Some students love presenting, others absolutely hate it. But by the end of their third year, they all really liked it. The competitions, I had my students always participate at least in one competition. Other teachers don't. They really don't care about the competition. Their thing is more having the students learn the scientific method and scientific discovery. So it would be a personal decision, really, what would be important to you or your school. The end of the school year symposium was a really big event for us, and a lot of people would go. That's how my program really started to develop a phenomenal reputation. And I really encourage all students learn to present, because that's important in the communication skills. Your JSHS, which is the Junior Science and Humanities Symposium, I don't know, does anybody participate in that, Margaret? Do you know?
I do. Unfortunately, I do not. I know that at least for the Vermont STEM Fair in Norwich, there are some, but it for being such a small state, Vermont is very like disjointed. So I actually just wrote down in my book the new I guess I don't know if you would call her the executive director of the Vermont STEM Fair, but she actually just emailed me last week and I said I would get in touch with her and I forgot. So it is in my to-do book. But definitely I will look into the JSHS. I guess it's the
It's at New Hampshire, University of New Hampshire, and I looked it up. So that's your region that you would go to if your students participated in that. The STEM fair, a lot of times the 8th grade does it and then they forget about it in high school. But this is the one that you keep going. Well, the JSHS, you go on as well to a national. So these would be the ones for Vermont that you would participate in. And so the upshot and the conclusion of it all is that we feel that if you could get all interested students who are interested in STEM, and this is a lot of times where it stops. They're interested, they take classes, and that's about the end of it. But if you could also offer a science research program and put that in a regular school, then we feel more STEM careers could be filled in the United States. And this also goes along with your 6 learner attributes that I actually got this. Margaret,
that looks familiar.
And it really does apply to science research. I mean, each of these 6 I had looked at and I was like, oh yeah, carrying out investigations and inquiry and analyzing data. Oh yeah, that's science research. And, even the essential concepts and constructing explanations. I mean, authentic learning. It really, really has to do, it's really a part of, even I had a lot of students who wanted to do something like slice mouse brains. And I would be like, how ethical could that be? I mean, it has to do with them really learning each of these learner attributes. So I really encourage anybody. Here's some of my students, some of my former students who are now working in STEM. Tyler is a PhD student at Columbia in microbiology and immunology. And he says, I would have never known what scientific opportunities were possible. And I would certainly not have not become the budding scientist that I am today. Emmy, who each of these students were involved in the program. I'm so grateful to have participated in the science research program. She's actually in her last year of pharmacy school. Dominic, same thing. If it wasn't for partaking in science research, I do not think I would be as successful in college. And Alexa, this early exposure to collegiate level scientific research gave me a tremendous advantage while earning a biology degree at UNC Chapel Hill, pursuing a career in medicine. And these are all regular students. I am like so telling you that these are all students. In fact, Tyler, who's getting his PhD at Columbia, originally when I got him as a sophomore in high school, wanted to be a music teacher. Nothing wrong with music teachers. I love music teachers, but doing science research really inspired him to continue in the STEM field. This is, I don't know, Margaret, I'm about 10 minutes early, if that's okay.
Yeah.
If anybody has any questions.
There were a couple, I'm scrolling up. There was a conversation going on in the chat that I totally was part of. One of the questions
I'm so sorry. I didn't
no,
even pay attention
like
to
this
the
is
chat.
that's like the virtual nature of, Zoom and everything. Liz had mentioned like, how do kids have time in their schedules? So you had said it was like 3-year program. Does that get scheduled as like a course?
Yes, Liz, we had it when I taught it, we actually had it as a course. It was a science elective. And I started with one class with 2 students. And by the time I ended my career in 2016, I had all 5 of my classes all science research. I had taught physics and chemistry, but I didn't even have any physics or chem classes. I just had a full schedule of science research. Other schools, I'm just putting a program into a school in New Jersey where they are instituting it within their, I think it's their biology, not that I can't remember the course name, but it's a biology course. And I think that's the thing that most teachers say, like, oh my God, I can't take one more thing to put in my schedule. How would I ever do this? But a lot of the students' work is independent. And it's amazing how the students, they just need like a once every 2-week checkup. How are you doing with your project? What are you doing? How are you doing? So, but I did have it myself as a regular course in my school. I believe, like Margaret had mentioned, when she went to high school, it was Long Island. I'm sure they have a regular course. I know.
Yeah, I had posts. I actually, as you were talking, I went back into the course program, and it was a 3-year commitment starting in 10th grade, kind of like what you had outlined.
Yes.
And that it was in their scheduling. Like if you were part of that, that was that would be like the first thing that gets scheduled, because
what I found was that a lot of the schools didn't want, and this was a problem, that they were like, yeah, we don't want it as a science elective 3-year course. We just want it like a 1-year course. So that's where with Science Research for All, we actually we modify the program so that it fits each school. If they want it into a particular class, or they want it after school program, perhaps they want it as an independent study program. This is where we modify it to adapt to each school.
It's interesting. When I was actually in the classroom, and I know that Shari and Liz, you are in Maine. And so as Vermont was switching and moving into like a competency proficiency-based system, we had an opportunity to go to Noble High School to learn about what they were doing and everything. And then later on, I and another science teacher went back because we were interested in what they were doing with their alt program. And something that I've kept thinking about. So, and this is all going to tie together, I promise. So like in Vermont, we have a flexible pathway initiative, which allows for personalization and flexibility outside of a traditional classroom. So how a student shows proficiency in the standards. And what I really liked about Noble was that if a student had like 5 performance expectations or performance indicators that they had to meet, and they didn't meet one of them, they could bump out of like a traditional sequence and then do like a project. I put that in quotations. And I'm thinking about it in terms of like how we would attend to something like that in Vermont, where instead of just having students bump out, building a course in which like we can say a student has to meet a certain graduation proficiency. Here are the next generation science standards, like this toolkit. What is your, like, what science research project would you, are you passionate about and interested? And looking at this toolkit of performance expectations you have, how can we build a program that can fit? And I could see like, there's a lot of moving pieces that are going on in my head right now, but I feel like this is a pretty an interesting thing. We have a policy, we just went through some policy academies and we're working on STEAM policy making, and specifically around like frameworks and, you know, how you actually build a STEAM program. And one of the buckets, we have no other better term for it than buckets, but like, isn't this idea of like an expanded learning opportunity and like community partnerships. And now it's like all of a sudden all these little things are coming together, and I was like, yes, this could be something that we can do, because right now we had a push for the first grant, which is like the robotics competition. And I was like, this would be a great addition to that, and work within the flexible pathways and work with personalization. And like, what a great opportunity to kind of like tie initiatives together. Like,
Yeah.
Wow.
Well, that's great. Well, you know, feel free to contact me. You know, my info is right there. And do you want me to put that back up, Margaret, or stop sharing, or what would you like?
If you want to send me your PowerPoint, because then I could embed it with this video.
Sure,
and
I
we'll
could
have
email it
because
to
there are
you.
a lot of stats in there that I'm like, yes, I want to pull those stats. I want to take a look at them in depth, because, you know, there is like, even with my own old high school, it was like, you have to qualify. I'm like, but why? We know that, you know, like, authentic learning engages students. Like, we should. And so there are I think there are a lot of hurdles. I don't think that they're bad. I just think that it's changing people from a fixed mindset to a growth mindset, you know? But yeah.
That's sometimes difficult.
Oh, yeah.
I always tell, you know, and then I promise I won't talk anymore, but I meet various teachers and science supervisors, and they are like, yes, we really want this program. And, you know, so we'll develop things together and we'll be in communication. And then you get to the central administration where it has to be approved. And it's like turning the Queen Mary. And I think a lot of times, you know, not many people understand science, and they're like, research, what? You know, what? So it is, like you said, it's many hurdles. And but we're trying. We are trying.
Yeah. All right. Well, thank you. I'm going to go ahead and stop the recording.